Hello, everyone. My name is Anil. I work for Brocade, and I am committed to the OVSDB project. And I have with me Sam. He works with Red Hat. He's a PTL of OVSDB project. I have the Flavio with me. He also works for Red Hat. Okay, and people who work on Neutron, OVSDB, OpenStack, they all know him. Okay. So
that's not a good thing, is it?
So that's going to be fun. And it's a 4 o'clock, California, and you all are here, house full. That's really great. Thanks.
Thank you.
Thanks, all of you, to coming here and joining us. So let's start with this thing. So this is how we are going to go. It's like 30 minutes. It's like we are going to cover all the stuff related to OVSDB project, what it offers, and related to that. And the 1 hour or 10 minutes, we are going to keep it for a demo. So we gave you a stick, so if you can copy all the OVA image by, this 30 minutes, that would be great, so we can directly start with the demo.
And
okay.
Do you want me to stick around here, or are you good there?
Wherever you like, man. You are the man. So we'll talk about these topics. First is what OVSDB project offers you. Why is the center of attraction? It's a fancy line, but yeah. Brief overview of Open vSwitch and management protocol, because this is something which we rely on this one. So we definitely go through that. High-level architecture and the control flow of the OVSDB and the network virtualization solution which we have in this one. What we have accomplished in a Lithium, we did a lot of job in a Lithium. So we'll go take you through that. What we are planning for a Beryllium, there are good list of to-dos that is in to-do. So we'll take you through that so you'll know what you will see at the end of the Beryllium. And let's stack, that's where we'll start our demo, and we need your OVS to be ready. And we are looking for a contribution. And if you are looking for a contribution, we have a PTL with us. You can always grab him. And me and Flavio is always there on IRC. OK, so what OVSDB project offers, right? So we are not talking about, in this slide, we are not talking about the virtualization itself. We are talking about the project itself, what all it gives you, OK? So the first and foremost thing that it gives you is provide you a network virtualization solution for OpenStack, which, from title, you already figured it out. The second thing that is the most important thing is the southbound plugin to configure the Open vSwitch. Okay, this is basically an MD-cell-based component which we have, which applications can consume directly. Okay, they can use just this piece of component from the OVSDB, and they can use it. We have a library to encode and decode OVSDB protocol because we all rely on the OVSDB protocol, so we have this one. Then we have a REST and RESTCON interface to configure the Open vSwitch. Okay, so RESTConf is basically exposed through MD-cell, and REST component is we have a northbound component that actually talks the vanilla REST thing, which is very raw in the sense it actually allows you to directly modify the tables. And we have a challenging software-defined networking problems to solve. One of the simple example is you want to kind of program a router without having any physical significance of the router, and it's not easy problem to solve. You can always ask this guy. So everything you have to do through flows. So that's challenging part. And we do have a lot of challenging problem that's lined up, and we are looking for folks who's looking for a challenging problem. Just come to us. We'll get you to on the same page. Why is the center of attraction? It's not I'm not quoting official center of attraction here for ODL. What I'm saying is, I'm just sharing my experience. When I started working on OVSDB, like in January sometime 2015, and Sam and Flavio, these were the guy kind of driving this one. Then I joined, and now if I see, right, there are 15 to 20 contributors across the industry. It's like Red Hat, Brocade, Cisco, Intel, HP, Dell, Extreme Network, and I might be missing 2, 3 more. So it's the whole ecosystem which we built in last 6 months, and there are a lot of contribution coming from these wide variety of organizations. So this is why it's kind of center of attraction for us. But let's go to the real reasons. So OpenStack integration, when I think Madhu and Brent and those folks started this project, the intention was to kind of provide a SDN-based solution for the OpenStack Neutron APIs. Okay, so there is this SDN-based solution, and that was what was there in mind, and they started with that. So it's a very, 15,000 feet kind of view where you have, a Neutron ML2 mechanism driver that is just a pass-through. Okay, it will pass all the APIs to your controller. And at controller side, we have, we kind of expose REST APIs. So that is a separate project we call as Neutron Northbound that actually receive all the REST APIs. And then we have our solution sitting, underneath that, and that provides you a network virtualization. So this is one of the main reason, we started this project, and we are very tightly integrated with the OpenStack for till now. Well, this reason is not very specific to OVSDB, but this is overall, a reason for ODL itself. So if you see, GBP or NIC or OpenDove, VTN, OVSDB, all these are basically a platform to kind of solve various problems in the NFV domain or overall in SDN domain. So they provide a flexible platform. They kind of solve your various range of problems. So that's one of the common use case, and that's the reason for the OVSDB as well. This is the reason which, people who kind of work on it day and night on OpenStack and ODL side, they might notice this thing. So Neutron is basically tenant-facing cloud networking API, but it's a poor SDN controller implementation. When we say controller implementation, we are not really referring to the OpenDaylight. It's basically a Neutron SDN implementation we are talking about. It's a complex architecture where, there are a lot of agents running on all the machines, okay? And they use custom protocols. Well, if you go by Open vSwitch kind of networking, it's like you have to run one agent on all compute node. There are a bunch of agents that are running on a networking node, and there are a bunch of agents running on a controller node. So there are a lot of agents, and the whole architecture is kind of complex. And there is a fundamental, scaling and robustness issues. You get to know these robustness issues when your system goes down. Then you realize that, okay, something bad happened, and it takes time to kind of recover from that. Neutron as an API service is focused on a tenant, right? It's kind of giving you a very orchestration engine kind of view where you manage your data center, but it's not very specific to network APIs, So this thing, there is no real APIs. When your system breaks up, it's like, if your networking is not working, you kind of need to check a lot of components on all the compute nodes and on network node and control node to figure out what actually is wrong, right? So that's very hard part of it. So there is no specific APIs as such here. So, okay, these are the problem set, but how ODL is kind of helping out here, okay? One thing is a heterogeneous networking. So they kind of take care of heterogeneous devices. You manage OVS devices, you manage OpenFlow devices, you manage netconf-based devices. So you have a heterogeneous set of drivers which actually kind of take care of all these devices. And the point is, if the controller is sitting on top of this, they provide all these functionality, you can always expose abstraction that actually works on top of it. Yeah. That's the kind of flexibility that OpenDaylight gives you. That's the one main reason, that it can help you to solve these pains. And the second thing is actually bridging a gap between you. So you have one side OpenStack devices, and the second side you have a lot of heterogeneous devices. So it's kind of bridging a gap between you, okay? So you get all this stuff from, it's basically pass-through instructions from OpenStack, and in between you have a layer that takes care of all the complexities. Okay, that's where it is another plus point for SDN controller to come into picture and solve that problem. So hardware support for offloading in form of hardware VTAP and L2 hardware gateway stuff. This is something we recently started. So folks from HP, Ericsson, Extreme Network, they are kind of working on it. We are planning to have a support for hardware VTAP schemas. We are planning to have a support for L2 gateway extensions. So folks are working on it, and this is active development that's happening as of now. Okay. So this is another core piece without which OVSDB project won't sustain. So I'll quickly go through it. Hopefully you know all of this stuff about the Open vSwitch thing. So Open vSwitch provides you Open vSwitching many features that is kind of helps you to kind of devices solution, virtualized networking solutions. It supports VLAN, tunneling protocols, LSCP, quality of service, ACL, NetFlow, SFlow, and all those things. It provides you a programmability and management interfaces, just like OVSDB, which we use in our project, OpenFlow protocol, which also we use in OVSDB project. Good thing is remotely configurable, so that's the thing which we extensively use, and it has many support for extensions like Nisira extension, which we extensively use in OVSDB project. It provides us some matching capabilities based on layer 1 constructs, layer 2, layer 3, and layer 4. So, and it provides you action like outputs, discard, resubmit, packet modification, like push, pop VLAN headers, and sending a packet to the controllers. And main and the foremost is basically centralized control. So that's what we are looking for. It's a centralized control, everything in a controller, and controller acting as an OVSDB manager, and it's also acting as an OpenFlow controller. So it's everything in a one controller. Okay, it's a centralized entity, and it can control both of these devices through remotely. Yeah, so this is high-level architecture about OVS. When we talk OVS, sometimes all the freshers, right, kids coming out of college, they actually get confused by you creating OVS, and then it's kind of OpenFlow switch, and some people kind of get confused with OVSDB management architecture kind of. So this is what actually the architecture is. You have a OVSDB server process running. You have VS switch D. Those are the processes that is running in a user space. Then you have a kernel module that is basically your data path. Okay, and in the context of OVSDB projects, OVSDB manager and OpenFlow controller both are basically same as OpenDaylight controller. Okay, but one component that is southbound plugin that talks to the OVSDB server, because it just wanted to do the configuration in the OVSDB. Like you want to create a bridge, you want to create a port, you want to add a port. All those kind of configuration of the OVS, that is done by OVSDB server. So OVSDB manager talks to OVSDB server. Now once we create a bridge, right, that bridge is not normal OVSDB bridge. That is something which we always connected to the OpenFlow controller, and that's how the OVSDB basically works, and we'll later cover all the details of that. So once we create a bridge and we connect it to the controller will talk to OVS vSwitchD, and it actually do all the flow installation, removal, and all those processes. All these OVSDB client, VSCTL, DPCTL, FCTL, all these are toolings which interact with these processes, and from a command line, you can dump the details and all those things. Yeah, this is pretty much I covered. So it provides it's a management protocol. So it provides all these, obvious stuff about, making transaction, monitoring, getting a schema, notifications, and it allows you to do operations on a database table, because OVSDB internal use the database table where it actually persists the configuration. And so if you have a database, they provide insert and delete operations, mutate, update, select, abort, and comment. So we exercise most of these things here in this one. You will see in the library code, you will see all those stuff there. Okay, so I'll hand over to Sam. Sam will take you through high-level architecture, control flow, and what we have accomplished in lithium, beryllium, and then we'll start with the demo.
Okay. Thanks, Anil. Okay, yeah, so we'll go through the high-level architecture, the control flow. See the picture, it's kind of a typical, the SDN architecture, applications, northbound APIs at the top, to the middle, the service logic, and down at the bottom where you're pushing out to the switches and things. And the core piece in there, you see the OVSDB block, the network provider. That's the network virtualization piece. That's the piece which does all the programming of the flows, OpenFlow programming. Takes all the Neutron interface, Neutron, network create, subnet, port, router, and the little reddish pinkish block, the OVSDB library, the important block, which Anil described the whole OVSDB library. That's the piece which does all the communication to the OVSDB nodes, does all the schema changes for us, and I'll go through the flows now, the actual control flow. well, okay, actually, I'll just show the pipeline. So NetVirt, that network Virt provider block that we had, it's all based off of pipeline. And for those guys here, probably a lot of guys here in networking kind of backgrounds, you'll probably recognize it's a pipeline. There's certain tables, you can see like the egress ACL, ingress ACL, inbound, outbound NAT, routing L3, L2 forwarding, pretty important. First table, table 0, is a classifier table. But everything in NetVirt goes through this table. And if you're looking at the NetVirt code, that's what you'll find. You'll find services that correspond to every single one of those blocks. And each one of them, you know, they're responsible for the flows to do that particular function. Okay, so now we're back to that. So in a normal picture or a normal flow, when everything's coming up, you've got your OVSDB nodes. You know, you're sitting on your compute nodes. You know, via set manager or however you get them pointed at the controller. They'll connect into the OVSDB library. That's that wavy one. They come into the library gets that connection, it passes that over to the southbound plugin. Plugin's MD-SAL based, so it takes that schema and it converts it into MD-SAL, writes it into the configuration, it writes it into the operational store. And that goes up to the MD-SAL block. The NetVirt provider is registered for any notifications, you know, any changes that are happening on that OVSDB topology. And so at that point, the NetVirt provider now knows, hey, there's a new OVSDB node that we need to worry about. And so the very first thing he'll do is he'll turn around and say, okay, well, I need, if, you know, everybody that's used OpenStack, there's always that integration bridge that's on all the OVSDB nodes. So that's what it'll write back into MD-SAL, the configuration. It'll say create you know, the integration bridge. And that comes down step 4, down through the southbound plugin, through the library, down to the node to actually, you know, tell OVSDB to create that node, to create that bridge. Next step, so that takes care of the OVSDB side. So now we're connected to the node. We've got the bridge. Now we need to start working on the OpenFlow piece. So we need to set the controller. And so at that point, what will happen, the OVSDB node, now that it's got the set controller address, which was from the previous step, it'll connect in through the OpenFlow plugin. That gets written off into MD-SAL. Also, as part of that, the OVSDB library notifies the southbound plugin that, hey, there's a new bridge. That bridge goes into the MD-SAL, gets written into the operational of the MD-SAL. And again, NetVirt provider is listening for those notifications. It sees that to the operational, says, okay, there's a new bridge. Now I've got a bridge, and now we go back to that pipeline that we talked about, that we showed earlier. And NetVirt will, and that's step 3, it'll go through to program flows, that pipeline flow, or that whole set of pipeline flows. Writes that in MD-SAL, OpenFlow, southbound plugin. It gets that data change notification that these flows need to be written or programmed. And then step 4, it pushes them out to the bridge to program those flows. And that's what it'll look like. You know, I'm sure everybody's familiar with the OVS-VSCTL show. You can see we've got the bridge. Well, you got the manager. That was that first slide that we talked about, how the node just connects in to OpenDaylight. That's the manager. Turned around, it created the bridge. It added the controller. You can see it's connected there. And off on the side, you can see the pipeline flows. You know, and right now there's nothing really on there, so it's just go through tables and then drop at the end. You know. Okay. So the next piece, from the top side, if you're adding the Neutron ports, you create the networks. The Neutron API comes down through from the OML2 driver, comes into OpenDaylight, the Neutron service that gets written away. NetVirt gets told of that. And it can't really do anything at that point, because all it really knows is there's been nothing physical that's happened. There's no real ports yet. As part of LiveVirt, when you're in Nova and when you're spinning up your VMs, LiveVirt also goes to Open vSwitch. Well, it goes through LiveVirt and it tells Open vSwitch, add a virtual port for these VMs or the DHCP namespaces. And so that'll get updated on the OVSDB. OVSDB will reflect that back to our OVSDB library, which is step 2, comes up through the southbound plugin, gets written into the operational to say, hey, there's been a new port added to this bridge. Goes up into MDSAL. Again, notification comes to NetVert provider. NetVert provider now knows that there's a port there, and as part of OpenStack writing, it actually writes into the external IDs. It writes down a reference to the port, the Neutron port. So from those 2 pieces of information, now NetVert can know how to build a tunnel. It knows that these endpoints are on these different OVSDB nodes, and it needs to go ahead and build that tunnel. So that'll be step 4. We'll write into configuration to say add VXLAN ports to that bridge. MDSAL notifies southbound plugin. We come down through step 5, and he goes and adds down through the library, and ports get added onto the OVSDB node. And then the last step, now that we've got those ports, the NetVert will program the flows in order to direct traffic to those VXLAN ports and across the tunnel. And again, another OVS VSCTL show command. You can see the port VXLAN 192.168.201. On the other side, the other node, the other OVSDB nodes will also have the peer port in a sense, remote IP, local IPs to build that tunnel. You can see the tap port. That's it's either from a DHCP or from an actual VM, which are attached to the bridge. And here's here shows some of the flows that are in the pipeline when that happens. I'm probably going to leave that for during the demo. We spend time on that. We'll show actually each step when we create the ports, add the routers, and we'll actually kind of describe those a little better. So let's see, same thing. Okay. So what did we accomplish in Lithium? So Lithium, OVSDB was one of the projects that's been around since helium. From hydrogen through helium to lithium. So it's all based off the old, I guess I don't know if you should call it old, but 80 sal based. Everything was 80 sal based. So that was a huge undertaking. One of the big things that we wanted to do was the GBP project, VTN, SFC. They needed the ability to use OVSDB. And it wasn't that consumable being an 80 sal based module, plus 80 sal was going away. So that was a huge undertaking, was to remove all the 80 salisms from the OVSDB project and slowly migrate it over to an MD sal based architecture. And that's what that first bullet is. Second one is the actual southbound. So take that, OVSDB is a schema. And again, to be MD sal based, you have to have that Yang model. So that's what that southbound plugin is, was to create that, take that Yang model and write the code there, the provider code for that. Next step was, once we had that, we can now move NetVert over to that. And so it would be MD sal based. L3 service, that was an important one. Flavio spent a lot of time with that. That's kind of a cool thing, and we'll demo that. That was a big service adding in. Floating IPs, DNAT. Last one, the SAL compatibility layer. That was VTN. VTN was a big consumer of the OVSDB project. They couldn't convert fully to MD sal for Lithium release. So we had to provide a compatibility layer for them. We've got improved unit and integration tests. We code coverage. We got that down at the bottom, but it's really not. It's actually a pretty high one. We probably should have listed that first. A lot of time went into unit tests. Almost all the code in NetVert is covered with the unit tests, integration tests. Flavio has spent insurmountable amounts of time trying to get the continuous integration with OpenStack working, the upstream. There's a lot of coverage there, and there was a lot of work that went into that. This is kind of just showing pictorially what we just talked about, I guess. You can see on the slide on the left, You see the little orangey yellow blocks. That's the 80 sal pieces, components. And you can see as we move to the right, they become MD sal based. An important piece in there is you can see on the right that Neutron project is in red. That was actually another big thing that we wanted to do for lithium. And you can see on the left side, it's part of the controller. There really is no Neutron block. I mean, it says Neutron Northbound, but it's really just a blob inside of the controller. A lot of projects were in the controller were just, it's kind of like a dumping ground for everything. It was just in there. Problem is there's a lot of controller committers, but they didn't really know anything about Neutron. You know, so the Neutron, if you needed fixes or anything changed in there, it was hard to get those things done, you know, just because they just didn't have the, you know, the skills to understand Neutron. So that was a big thing. We pulled that out, created a new project. Flavio's a committer on that project. Ryan and Ed, they've done a really good job. And back to the, you know, the integration and unit test, they've done a real good job on, you know, again, making that a much, much better project now. And the code is much more robust. And it's moving towards an MD sal. It's got an MD sal interface, and that'll be something that we'll be moving towards for beryllium. It's kind of another continuation. What this shows is that OVSDB plugin, whereas it used to be 80 sal based, it's now MD sal based. And the NetVert provider is now MD sal based. And then we go to the final picture where you see that plugin went away. And now we just come down through the MD sal like every other, you know, like a proper MD sal application. The NetVert's now using the MD sal. Okay. What are we planning for beryllium? It's a pretty big list, as you know, as Anil kind of described. You know, in an OpenStack world, there's a lot of features. There's a lot of use cases that OpenStack, when people are using OpenStack, and so we're kind of a lot of the features that we're working on then is feature parity with Neutron. Try to keep up, you know, and to cover all those cases. And plus, though, there's no real. Well, it's an open ecosystem. Anybody that's willing to commit code, work on these things, you know, you can add these features if you need them. The architecture is pretty. It's pretty flexible. You can add in anything you want. Well, I shouldn't say you can add anything you want, but it's fairly easy to adapt and to, you know, to add your features. And that's why the list is pretty big. First one, though, the important one, I think everybody's moving towards, you know, HA, scalability, clustering, performance improvements. You know, as a first step, moving towards MD sal was, you know, that gets you part of clustering. We've got to move the northbound, the NetVert northbound, whereas now we're reading from Neutron. We need to move that towards an MD sal based to get that further along. Code quality, stability, of course, testing coverage, documentation could be better. New OpenStack services. We have some implementation of security groups. Ashwin and team, I guess, from Dell, they're doing a lot of work on that to beef up the rest of the security group support. Allboss, there's an implementation of a load balancer. There's a couple tweaks in there. It was kind of, when it was first implemented, it was in between version 1, version 2 of the LBOS spec. So there's some updates that need to be done there. Implement the SNAT. We've got the DNAT. SNAT is kind of a bigger problem to tackle. So that's what's coming up. IPv6, firewall as a service. Another fun one is you know, the service chaining, NFV integration. Hardware VTEP, that's coming on pretty strong. Large group of, it's multiple companies, right? Looking at adding VTEP support, L2 gateway. And that's another big use case for us in order to be able to do, you know, top of rack offloading for the switch, for the hosts. And I mentioned the moving NetVert to the Neutron Yang models and continue growing the ecosystem. Oh, and now the fun time. Yeah.
So I just start by saying, I don't take credit for this. Sam did a lot of that work, so please don't just give me kudos. It's really these people there too. So what do you want to do? On the demo, we have the OVA file. So we're hoping most of you guys have VirtualBox, which makes it somewhat seamless. Sorry, Daniel. So once you open that OVA file, and if you do import appliance, if you haven't already done so, you should be able to see 3 VMs in there. So let me, and well, I guess let's start by what we're trying to do here. So with this demo, we're trying to show you guys the DNAT functionality that we introduced in Lithium for the L3 forwarding, which is for the OpenStack folks. The way we do it here is very DVR-like. We have a fully distributed way of doing forwarding, except we don't have a real IP stack. We just use open flow rules to accomplish everything a router would. That comes from decreasing TTL to replying ARP, changing layer 2, all the fun stuff a router would do. We can do it with OVS and ICR extensions. So yeah, from that OVA file, you should see 3 VMs. And I don't know if you guys, if there's anybody having trouble, please raise your hand and I'll have my helpers here come over.
And if you're facing any problem, just let us know, okay?
Yeah.
So we can help you out to fix those.
Yeah. So basically, once you start those 3 VMs, then you can, yeah, you can just go ahead. I guess one of the things is to get into them, you can get to their console, of course, but you also, we created an Ethernet interface on them. That is the VBox Net 0, normally the host-only network you guys can get to. Now, they are hard-coded with the 192.168.50 network. So with that, if you don't mind, I'd like you to go to your VirtualBox settings. So here's VirtualBox. Oops, you see that? So if you go to network, and then on the host-only networks, I have a bunch of them, but the one that's really important is VBox Net 0. And make sure that's 50 on the 50 network. So that will, once you have that and you have those 3 VMs going, you should be able to get into them from an SSH. We're not using the HCP there, so you don't need to worry about that. Does it make any sense? Let me know if you guys need some more info. All right, so now back to our slide here. So you got the OVA guys, import appliance. Do not mess with the Macs if you can. That would just make it easier for us on the demo because we have some hard-coded values on the Mac. So you keep them the way they are. And you start them up. And at which point you should be able to SSH into them. Basically doing that, SSH ODL at 192.168.50. 31 and 32. You guys okay so far? Whoever's trying this? Yep. The amount of RAM. I think you can tweak that. I think Sam was being a little conservative about. Yeah, I think if you have 4 gigs for.
Yeah, it's hit or miss because what we have, and Flavio described, we have something called an all-in-one node, which means it runs the OpenStack, the control node, plus it runs OpenDaylight within that node. And during startup, it's very, very hungry. So it's
I'm able to get it working with 4 gigs. And the compute node, you probably don't need more than 2 gigs.
Yeah, the compute node, you can get by with 2.
Yeah.
Yeah.
So if you're running out of memory and you need to tweak that, that's probably should be all right to do. Good question. And once you did that, actually, I'm just going through the steps here, and I think this is probably the one that will take the longest, so I'll have you going there, and then I'll explain the rest of the story. So if you go into these 2 SSHs, and on the 31, you just cd into /opt devstack, and then run /stack.sh. So that will basically start OpenStack with the Neutron ML2 networking ODL, which we'll be talking a lot about tomorrow, me and Armando. So if you want more of that, we can talk about later. But if you then run stack, and that will start OpenStack and ODL in the control node. And I'll show you a picture of that shortly. We're going to end up with something that looks like this. This is the later picture. So maybe let me start with, I think Sam was being, yeah. So this is really what you end up with to start with. Questions? Everybody okay? Want to go back? Oh, I'll definitely go back. I just want to give you a feel for what you have right now once you've done stack.sh. Where's the what? The slides. They will definitely be. They are. I think I have them on the sticks. Yeah, but we'll definitely have them on our ODL, Open Summit. I'll make sure they're available. Yep, it's the wiki page of the ODL Summit. Thanks, Daniel. Yeah, but yeah, definitely make this available to anybody. So, all right, so let me go back here. So, we got that. Is anybody who's trying this having any trouble? Who's done stacking? Anybody's finished with the stack? No yet? Okay. All right, takes about 4 or 5 minutes. Yeah. Good? All right. Yeah, I'm sorry. I don't mean to make you dizzy. I just trying to give you a feel for what's to come. I will go through the steps one by one, so don't feel like you're missing out on anything. Just don't get too seasick. Yes, you are okay? Sam? Okay. All right, I want to get a show of hands later, maybe another minute or two of how many folks have managed stacking. Okay, all right. So this is what we're going to accomplish later on, just so while we're waiting. So we're going to have these two compute nodes, there are really 3 VMs. One of them is the router node, and as you see, all it's doing here is connecting the BREXs to the outside world. So it's just offering a way out of a VirtualBox. And it's more like a typical, OpenStack deployment. And Armando, you were talking earlier about the BREX and why is that we're talking about the public interface. So this is part of that. And then OpenDaylight is running in ODL 31, as you can see there. And that is the back end of Neutron. So normally in the OpenStack world, you would have the L3 agent and the L2 agent. In this particular case, and I'll show you the local conf, we're not using that at all. We're just delegating all that job to OpenDaylight. So we really simplify OpenStack's life a lot. Then later on, we're going to create 2 VMs. As you can see, VM VX1 and VM VX2. They are actually in 2 different in 2 different nodes. And we're going to have a VXLAN underlay connecting those 2. So that's how it gets east and west traffic. Now for north and south traffic, it's going to use these patch ports that connects the BRINT to BREX. Of course, this is all through the magic of OpenFlow. The user does nothing about, to get that. But basically, from that point on, when you're going north and south, and through the OpenFlows, by some rules that I show you, we're able to get in and out, and we can do the ping google.com test to it. Okay. So this is the topology of what we deploy. So later on, we have the 3 nodes, those interfaces. You see ETH2 on the nodes themselves, on the VMs. They don't even have an address at all, because really they are just added as a port of BREX. What's that? Yeah? That is just a dumb, silly VM that I had put together. And all it does is offering DHCP and actually, not even that. It's just offering you a way out of your environment using ETH0. So it's just emulating a router on an OpenStack scenario, but it's really not doing anything special at all. It's not part of OpenStack, not even part of ODL.
It's running CentOS, right?
It's just a silly thing running CentOS, yes. It's just doing NAT, really, as NAT, yeah. Say it again? In DevStack? Yeah, yeah, yep. Anybody done stacking by now? Should be done by now. Oh, I think I forgot to do that. Step 6 there, you want to do the same exact thing on the ODL3 compute, and that's very fast, so it's just a few seconds. I don't know if you guys, whoever, haven't done that yet. And what that does is basically, it's going to come up, and it's going to have the manager, the OVSDB manager set to ODL, which is running on the other compute node, and wait for the bridges to come up. Yeah, how's it going?
Are these slides somewhere on the...
They are in the dongles, and we have them online as well. I don't have it.
Can you explain a little bit about what's that stack.sh?
Yeah, so definitely, if you guys are ready to talk about that, we can talk about that next. But basically, yes. So what I have here, so I have basically, I don't know, for the DevStack folks, I have local comps, and first thing I wanted to mention is we like disabling all services and methodically enabling only the few services that we want to use here. We are using the ML2, networking ODL ML2, so that's why you'd see in red here, enable plugin networking ODL, and that's just using the demos thing. We are using ODL L3, so we basically, with this, we're telling OpenStack to not turn on L3 agent, not turn on L2 agent at all. So that's why you won't even see QL3 enabled up there. So, and on the compute node, you enable even fewer services, right? You're just enabling the NCPU Neutron. And as you see, the public interface is what takes it to connect it to BREX. So, all right, I see some folks walking around there. Okay. I think Jamo, you look like you stacked.
Yep.
All right, good.
So when you say enable service, are you actually running agents on the compute node or?
That's right. So I'm actually disabling, right? So the very first line you see, disable all services, and then I'm methodically enabling just the specific ones. Yeah. So yeah.
Then why do we need the Neutron to be enabled on the compute node?
So Neutron as a service in OpenStack, it has two parts of it. One is it doing the actual work. The other one is delegating that work to somebody. And it's kind of confusing in that it's still Neutron. So we're using OpenStack and the Neutron as the service API. It's a way of like telling whoever is handling it, you know, what he needs to know. Create this network, create this subnet, but not really doing it. It's just passing in through the service API to ML2 the calls to have ODL know, oh, okay, somebody needs a network, and he knows how to do so. So that's the only job Neutron is doing in this demo.
That part runs in the ODL controller, right?
The Neutron service runs in the Neutron or the network node of OpenStack. So yeah, so that's usually how you have it deployed. It's just that a lot of folks, when they do that, they also have Neutron do the work itself as well, which is what we turned off here. We're having ODL doing it. So, yeah. Yes? That's right. So the question is, we have 2 VMs, and how does that connect to ODL, right? So yeah, so there's only one control VM and one network VM. In this case, it's just one, the ODL 3.1. But you could have potentially 33, 34, 35. And those are what they call the compute nodes in OpenStack. And all they need to do is to connect to ODL as their manager. So you're correct in that ODL is the one manager that is orchestrating, the creation of bridges and tunnels across all these nodes that it's going to do later. But of course, in the AJ world, which you're going to have, it's just this one way of connecting to ODL. But ODL is distributed in AJ, so there's protection and high availability there. But they are, as far as OpenStack is concerned, they are all connecting to this one entity as the manager for OVS. No, when you have multiple instances of ODL, that's when you need to configure it as an HA. So they really are orchestrating this whole thing as this one entity. And active-active, yes. Yes. Yeah. You guys all right? How's it going? Can we move on? So you don't need to do these right now. We can do them as we go along. I have following up steps that will go one-on-one and then show you what's happening visually. But in essence, we're just going to basically source OpenRC admin. Actually, I should do it as well so you can see it. So where is my VM? Oh, that's not it. Right. So this is my '31, and I think, yeah, I have it stacked. So cd opt left stack, then source admin like that. And if you do Nova list, you won't see anything because I haven't created anything yet, but just so you know. Oh, there you are. So the very first step is adding. Right. So once you stack, you're gonna have these bridges. And one thing I wanted to point out is it's actually ODL that created them through the OVSDB interface. ODL is perfectly capable of creating these bridges. So if you do OVS cattle like that, you see how I'm on the control node, and then you have the integration bridge, right? The brint, as well as the brex. and then the point to make is to see that the manager, this is like what you're asking, every node is going to have that set. So they know how to connect to the one ODL that's managing and orchestrating that. And like I think Anil was pointing out later, that orchestrates the creation of the bridges themselves as well as ports in that bridge. One thing that we do on that slide showing you that we create a patch port to connect brint to brex, for instance. That's all done through OVSDB. Okay. And this is the initial pipeline I think Sam was talking about earlier. So you have that here. Like that. And this is my ODL 31. I should just go to ODL 32. Yeah. Yeah. Same thing. Okay. So yeah, so here I'm gonna start. So here I'm gonna create the network. So that's what that step is. I think Sam. Right. So see that? Are we ready to move on? I don't know if you guys are stuck or having trouble. Okay. So at this point, we're just gonna pretty much create external network and the internal network, and then add subnets to them. So basically, just the basic networks where we have the tenants created on, and then we'll do it later on, create the VMs. So that's what that is. So, excuse me? Right, so once you did that source OpenRC admin, it actually doesn't matter where you do it, as long as you do it under, because let's control node, but it really doesn't matter. Yeah, so you just go to, just make sure you are in opt dev stack, and you've done that source OpenRC admin, and then from that directory, do that just like the way it's spelled out like that, ///tools os add nano.sh. And I think, Sam, you had what it does, right? Somewhere in here. Don't mind me jumping around, guys. I'm just trying to find add nano. Oh, sorry. So this is really it. The add nano.sh. It's basically creating the flavor that we're going to boot our tenants with. The nano flavor image. Add admin key is also pretty boring. It's basically creating an SSH key that gets to put into the VMs, so you can SSH into them without providing a password. The third one is the more fun one, which is what I just said, is you're really creating two networks, an external network and an internal network, and then adding a subnet to them. Note that on the external network, we don't use the HCP because we want the external router to be the one responsible for taking you in and out with the floating IPs. And the internal one, you have the HCP enabled with Google's DNS server. And then you create a router, right, which connects those two worlds. So actually, let me go ahead and do these steps so you can keep up with you guys. So I'm here. Already did that. Tools. Add panel. Yeah. Go ahead. I had trouble here. I'm sorry. Go ahead. So yeah, it's kind of an inception. It's a VM inside VM. It's a nested VM that we're actually creating here. The tenant VM is a VM inside the OpenStack node, which happens to be a VM. But so yeah, that's part of the, through OVSDB, you have all sorts of QoS attributes that you can add to the ports. And those actually come from OpenStack. And so, right, so in part of the Nova, you can actually tell how much network, how much compute you have, how many tenant VMs you can put in a compute node and all that. So OpenStack is pretty much orchestrating that and telling through Neutron to OpenDaylight to actually do the plumbing. So. So yeah, so actually that's, yeah, we're not showing you that basically, but yeah, there are pretty much attributes on OpenStack. I should actually mention, we have a horizon here. So that's more like of an OpenStack question. to that. So as you create, in OpenStack, you have attributes about how the tenant VMs go and all those things in there. So that's basically that part. Right now, I think I created any network yet, so the topology should be pretty boring. Yeah. So now let me go back here. I was having a little trouble. Okay. Okay, so this is probably because I already done this command. So it's just telling me, you dummy, already done this. I'll do this again. Probably have already done the other one as well. Tools, OS, add admin key. Okay. So that's that. And then I'll go ahead and create the networks here. OS. Add ext. Add ext net higher. Tools. Why are these not unique enough? Okay. Do I not have it? Can't spell. Yeah, nice. It does. Yeah, it does. Cool. Should have you up here, Jamo. I'm doing an awful job at this. All right, guys. So, all right. So actually, the picture got updated here on my horizon. But that's basically where we at so far. So we have the internal network, the router. Mind you, this is a virtual router. It doesn't really exist. In fact, in OpenStack, if you used the L3 agent, you would have had a namespace created for these two networks. But because we are using ODL, you don't even get that. You just get a namespace for the DHCP service, which is managing the internal network, the VXNet. Yeah. And I can show you a little more of that here. So if I do net space, so you can see the only namespace that we have is the DHCP. A couple ports showed up here, as I mentioned. First one is now I have built this patch port that connects BRINT and BREX, and that's so that nodes can actually, tenant VMs can actually through OpenFlow get to the outside. And to do that, we pretty much connect BRInt with BREX with these ports. Okay. Next step, this will be actually creating the VMs. So here, we're just adding 2 VMs, one on each node. Let's just go ahead and do that. You guys follow so far? Is that all right? Okay. Add VMs. OS. VMs. Yeah? The route is all done through OpenFlow rules, which I'll show you in a minute. Yeah. Well, that's a good question. So now we should have 2 tenant VMs. From this picture, you cannot tell, but they really are tenant VMs on each one of the 2 nodes. But they are logically connected to each other like that. So for all intents and purposes, they are on the same subnet. Yeah, yeah? Oh, okay. Yeah, I'll make sure I'll get it to you. You can, yeah, easy. So the last step is just to add the floating IPs to these VMs. So if I do, see that those VMs have the internal network. Tools, OS, floating IPs. So there's one for add VMs, and then there's one for add floating IPs. Yep. So. Okay. So now if I do my Nova list again, you should see their internal and their external addresses. Cool? All right? Good, I'm glad. You guys are awesome. It helps to be with a bunch of smart people. All right, so what have we done so far, right? So basically, we have 2 nodes, and that's what I have, those 2 tabs up here. You can see up there, the 31 and 32. If I do OVS show cattle like that, you basically see the bridges. You're also going to see some new ports in there, namely the patch ports, which I talked about earlier, but also you see these tap ports. And this is there's, on BRInt, you're going to have 2 tap ports, one for the DHCP service and one for the agent, for the tenant VM. I'm on 31, so you can see there's only one in there. On BREX, you see that ETH2 has been put in there. And then I'll jump to the other guy, ODL32, and do the same thing. OVS. I use text expander because I can't type, so things just makes it faster. So to get into the VMs, they are ODL. User ODL, password ODL. Yeah. So this is ODL. So yeah, so the VMs you created has this, oh, that's a Cirrus Cubs win. Yeah. And actually, Sam wrote a nice script that gets into them easier if you want to do it that way. So if you were in ODL 31, you can do /tools OS SSH like that, and then the IP address of the VM. So it'd be 10. What's that? 10.5, 10.100.5.3. 5.3. Yeah. So now I'm inside the nested VM, and you can see its password. And you should be able to ping its buddy, 10.100.5.4, right? Even though, so what's happening here, it's actually pinging its buddy on the other side, so it's actually going through the tunnel. And that gets into the OpenFlow rules that I should talk about next. So this big ugly line here pretty much shows you the OpenFlow rules. And that's to answer your question. You're asking how do we route if we don't have a router? Well, we basically do the job of a router. So, and this kind of gets a little heavy on the OpenFlow part of it. And I don't know if you guys are all that interested on it, but basically through tables, we have tables for replying to ARP. And that's what these table 20 in this case are, where we pretty much matching on the ARP packet. The ARP, this is distributed ARP, by the way. So in OpenStack, you have L2 population. So you pretty much contain the ARP broadcasts to be confined within the node that they're happening. So you don't really have any bandwidth across nodes being wasted for ARP because they're replied right up on the spot. So when a node ARPs for the router, it just hits one of these rules, namely the 10.100.5.1. That's the IP of the router. Table 30, that's the floating IP table. So this is how we get inbound net to work, in which case we are we just matching on the patch port. So when a packet comes in on BREX, because of virtue of the patch ports, it shows up as the patch int of the BR int port. And we're matching against exactly that. So exactly, I highlighted the wrong line. But basically, you're matching on that port, and you identify, oh, this is the floating IP for this host. So that's why we're getting the match section of the floating IP, and we pretty much rewriting the destination IP to the internal. And we also squirrel away the segmentation ID that it belongs to into reg3. So that's how we know, that's how we can handle overlapping IPs, because every tenant can actually use the same exact IP range. So we need that to differentiate it. Table 60, that's the table that does the routing, basically. So in this case, it's two halves of it. The first half is identifying the destination's network it's going to. And then we're pretty much doing what a router would do. We're doing the rewriting of the source MAC to be the router's interface, doing the decrementing TTL, which a router would do. And we just setting the segmentation ID to be of the new subnet that is going to. Table 70 is doing pretty much the reverse of what ARP would do. We're basically looking at the exact tuple, the tunnel ID and the IP address of where it's going, and then setting the MAC, the destination MAC of that tenant VM or the DHCP. Table 90 is the security groups, which I'm kind of skipping over for now, just on this demo. table 100, that's the table for the outbound net. So table 100 has actually two parts, and if you look at it, the first part is you identifying destinations, well-known destinations. So you identify the east to west traffic, and with a lower priority, you have rules for the floating IP. So assuming a packet is not going to these well-known destinations, there are the east-west destinations within the tenant subnets, you could potentially fall into this rule where say, okay, is this the MAC of the router as a destination address, and is this from the internal address that belongs to the tenant VM? In which case, you're pretty much setting the field of the MAC of the router outside your network, the one that is used as the gateway for BREX when we configure it, and then doing the routing as well, decreasing TTL, and setting the source IP to be of the floating IP address. So, and then table 110 is basically the layer 2 forwarding table where you're handling the broadcast multicast packets as well as the known DA packets. Now, see how we have 3 entries here, 3, 1, and 4? That's because we know all the MACs of all the nodes. So we know to, when I was doing the ping from one tenant VM to the other, it knows to go through the VXLAN tunnel. So you see these outputs 3 and 4. If I do this, you can see the open flow that each port belongs to. So in this case, I can tell that port 1 is the port of the VXLAN, which is this guy right here, right? VXLAN. Yeah. Output port. So, does that make sense? So I guess for the other final test, we should do our pings. So we can do an slookup. We will come. And here you can see how we can actually, from the tenant VM, go out through that little router and back using the floating IP. And ping. I don't know if Yahoo is pingable. Oh, no. OK, so it is. So, makes sense? Any?
I thought I saw a slide that SNAP is available until the relay.
That's right.
Show me an but where did that come from?
So right, so there's SNAT and DNAT, right? On DNAT, with what we're using here, it's a one-to-one mapping between floating IP to internal IP. That's called DNAT, correct? Yeah. In SNAT, now you're sharing that one IP to all tenant VMs, and that brings all sorts of challenges because you need to have some good control of simple things like who replies to ARP to that IP address. If you have this many tenants across and only one place to reply to it, you need to have some sort of a agreement of who handles it, and if a packet coming from the outside in, how does it land to the right place? So you end up having this one node that has to be responsible for it, and he has to delegate to the various tenant VMs instead of what we have here, which is a completely distributed way of handling the floating IPs. So, see if I get anything else interesting to say here, guys. Right, so networking ODL. So networking ODL is what Armando and I, folks have been working on to get the connection between Neutron to a third party, orchestrated for doing the networking piece. They had this concept of a stack forge. We'll talk more at length tomorrow about it, but it's now networking ODL is being pulled in back into the Neutron umbrella. So it's a formal ML2 connection to Neutron that it's supported by the OpenStack community. There are different ways of running it. The way I ran it today, we had OpenStack and ODL running inside the control node. It doesn't necessarily have to be that way. You can actually have ODL running outside. So they're just different flavors of how you deploy it. They call it ODL mode. Local conf, we kind of went through that already. Steps, we kind of covered it all. Oh yeah, by the way, there's this tools do it all.sh that does all the steps at once. That's actually a probably faster way of doing it all. So yeah, the picture, you guys have pretty good flavor for it. The rules kind of ran over that, patch ports. Yeah, so here on the slides, you guys are going to have this, so you can have a better feel for it. But it's basically going through the various rules and what they do. Okay. Right, so this is the before and after picture when we had just the network and the router and then the tenant VMs added. This is what the OVS port show looks like. Right, so this is, once we create the floating IPs, we actually need to respond to ARPs on behalf of that floating IP. So there are extra rules that get added on the control, wherever that tenant is. And that's what I think it's being shown here. Okay. So right, so I guess we already done that, but a way of getting into the tenant VMs from the outside is basically you have to do a little trick in that you go to the namespace of the DHCP and then get into the VM. Otherwise, they're completely isolated from the control from the OpenStack nodes themselves. Yeah, and then I guess put a shameless plug here, Mike. There's this tool that I wrote not too long ago that actually kind of shows you a better way of representing the bridges and the ports, with the OpenFlow ports that goes with them that show OVSDB and the sal.py. So I guess you can actually run it from the nodes. Let me just go here and then do opt tools. Show OVSDB node, and I think I need to tell where ODL is running. So that's what this is. So I think it's IP. Let me do a help. Right. So ODL IP 192.168.50.31. And the port, I think I need to tell the port we're running on. Is that port 87? Yeah. And now I'm dumping all the rules. Basically, this is just a little easier on UI way of representing the bridges. So every bridge has an OpenFlow name, and I have a little alias to kind of give you a correlation of what they are, and then the ports that interconnect them. We have LLDP running, so we actually have a good way of knowing how ports connect to each other. Even the VXLAN ports, the ports that had the tunnel ports between the BR ends, you can kind of see it through here and what they are. And now it doesn't really matter where you do this from, right? Because this is coming straight from the RESTconf on ODL. So it's all coalesced into one global view of the world. It doesn't really matter who's calling this. What's that? Oh, you want to see the command? Yeah. if you do this from the old L31, you probably don't need to do the IP part because you use localhost by default. And yeah, I did the -F. The -F is actually to not show the flows. If I take it out, it gets a little chit-chatty. But basically, those are the open flow rules that got pushed into the various nodes. The tables, you can kind of see from the names what they do and what they are. Right, so that's a sample output of what that does, what that is. All right, Anil, Sam, are you still here? Okay. Yeah. So basically, yeah, we just kind of jotted down the various commands and how to get involved. The OVSDB project, it's part of OpenDaylight, so you can clone it just like that. It's on a wiki page. It's just like any other project in OpenDaylight. It's a Maven-based project. So the config for setting the controller. Yeah, whatever OVS can offer, we leverage, which is really nice. I refer to OVS as the workhorse of all this. We just configuring and plumbing around and having it do the hard work, including QoS settings and all that. Yes, absolutely. These come from Yang. So that tool that I was referring to, the show Pi, if you look at it, you can actually take a quick peek at it. But it's basically, yeah, it's basically grabbing through RESTconf what the MDSAL on OpenDaylight is at that point and presenting it. So it's 100% open, OpenFlow. It's using the OpenFlow plugin, which is 100% MDSAL based. No, yeah. OpenStack is completely oblivious that this is all happening. So it's just telling OpenDaylight, hey, I need a network. Hey, I need this tenant. And by the way, he needs to connect to his other buddy. So yeah, it's actually, I don't know how much OpenStack really cares or wants to know about these gory details. And my gut, I suspect it doesn't want to know. This kind of level of details is actually what it's delegating off of, to the SDN controller. Yeah, so that's a good point. You basically orchestrate, and then I guess that's another subject when we're talking about SFC and OV, and Open NFV, is that you have other attributes that are not even pertinent to OpenStack that needs to come into OpenDaylight yet through a different way. But yeah, they really are domains of expertise, and depending on what you need to know, this is the right GUI, the right place you're going at to do it. Good question. Anyways, this is that. Config. Basically, this is just a bunch of Neutron and OVS commands. And I guess the next slide is asking for helpers, people interested in joining in, which we talked about a bit already. Yeah, so that's the wiki page for OVSDB. We have meetings, 12 o'clock Pacific time. Pull in the code, ask us questions. Anything else to add, Anil? You guys should come up here and take some hard questions now, both Sam and Anil. Come up here, man, so they can ask you some hard questions. I'm done. Well, I hope this made sense to you guys. I don't know, it was a little bit rough on the edges here and there, but you guys.
It's too much of detail. But
It was maybe, yeah.
At least we have these on slides, so you can try them. We have our, we risk it. We have our name on this last slide. You can ping us about this slide anytime, So you try it. If you want to try it some other time, you just give it a try. Use the same VM image, and we know it works. Okay. So, and if you get stuck anywhere, just feel free to poke us on, we are on OpenDaylight OVSDB IRC mailing list, and you will find one of us 24/7 there. So we are pretty reachable.
If you're curious about the Neutron side of things, tomorrow Amanda and I are going to be focused a little more on the OpenStack side of it. So we can get from there to the Neutron northbound, which is really not part of OVSDB, like Sam saying, it's a project on its own. So any NetVert, anything that cares about interfacing with Neutron can leverage it.
And on Thursday, one of the unconferences, again, like this is Beryllium release planning. You saw that big list of features. So we're going through that planning list. So if you want to be on that, the Thursday call or the Thursday meeting, the unconference.
Yeah.
Thursday and Friday, I think we are having 2 sessions. So are we planning for release? I think there are topics, right, which they'll put out and say, these are the topics for 2 design forums.
Yeah, they're already set. Yeah. We've got sometimes. I think the schedule's going to change, though. We're trying to move the timing around.
Okay.
Because there's a bunch of overlapping ones. But yeah.
Okay.
Any questions? Make any sense to you guys? Oh,
I got to
excellent.
upload those.
Thanks, Daniel. Thank you.
None of you guys are logged into IRC at the moment. I wanted to contribute.
Oh, is it? That's not possible.
My robot failed.
It's impossible to ignore us there.
Well, thanks, folks.
Okay, thanks everyone. Have a nice evening.
Yeah.